That's where the fun or the joy comes from me, when you see that sort of moment where someone goes, wow, now this is going to transform the way we do this. I wish we'd had this on this project.
A picture is worth 1,000 words. This was a statement invented by an advertising executive, Fred R. Barnard, in 1921. We've come a little bit further than static images in the 102 years since then, with technological advances within both digital and imagery. 3D is now a reality. Virtual walkthroughs are possible, and project management, what was once lines on a spreadsheet or even a piece of paper, can be brought to life in a visual presentation backed by data. There are so many visual tools available, it's difficult to keep track. And with the exponential growth and development in AI, this doesn't look like stopping anytime soon. We are just beginning. This is not to say that all of them will stand the test of time. History tells us that the cream will always rise to the top, even when there's little competition. Think Betamax and VHS, HD DVD and Blu-ray, or PlayStation and Xbox still battling it out. But how does this happen? Is it simply survival of the fittest? The best tech wins out? Or do we look to the experts to make these types of decisions for us? And we simply follow. Within construction, it is never that simple, as one size never fits all. So, what we tend to rely on are people who know more about the tech than we do, people who can spot the good from the bad in terms of what is right for a particular organization and for particular scenarios. This is where our guest joins the party. Today, we're joined by Derek Lawrence, a chartered building service engineer and reality capture consultant with experience in the design and operation of the built environment. Derek advises organizations on the benefits and practical implementation of reality capture, AR, VR, and photogrammetry technologies. Derek, in his own words, is absorbed with the idea that reality capture will positively impact the way we design and shape our built environment. And as you can imagine, Derek has a wide and deep understanding of evolving digital tools and techniques that will improve the way we design, procure, build, operate, and decommission our built environment. But we can go a little further than this, as Derek is equally interested in the artistic misuse of technology, providing a what's the point in this technology approach to his work, or as Derek likes to summarize, I play with technology. Derek, did I miss anything off that? And welcome to the podcast.
No, I just it was I was just thinking, oh yeah, no, I do that. That is, yeah, that's what I do. No, that's good. It's a pretty good summary. So thank you for that introduction, Peter. Much appreciated. And thanks for inviting me along.
Excellent. Yeah, pleasure. Thank you so much for joining us. I'm really looking forward to this because it's got a lot of photogrammetry words in that I can't pronounce or even spell. So this should be really really interesting. So let's kick this off and start with kind of the basics. So I'm going to try not to insult anyone's intelligence here, yours or any of the listeners, but on a basic level, uh, most tech that utilizes photography or imagery will follow the basic capture, compute, create. But within each technology, there are nuances and differentiations that provide various benefits that others don't, and some are very comparable. So let's start at the very beginning. And what is photogrammetry?
Yeah. So well, photogrammetry is loosely the process of creating a 3D model or 3D representation of reality by taking photos. And yeah, so the workflow to doing or recreating something in 3D is simply take a load of pictures of something in a non. I mean, when you take these photos, so you take them in a way that you wouldn't take your holiday photos. So you take hundreds of photos of pretty much the same thing with the same thing in most of the photos. So a key to photogrammetry or successful use of it is to have overlap between the photos and that's important because the computer then takes those photos, finds key points that are unique to those photos or common points, and then magically works out where all the photos were taken from, which is sort of the triangulation process, and then is able to reconstruct initially a point cloud on that, so lots of dots, and then that can then be, all those dots can then be joined up into a mesh and then given the color from the photos. So that's the realism. So you get the shape, and then you apply the texture to the shape, and that will create, for all intents and purposes, a 3D representation of reality. So that is photogrammetry. Interestingly, that sort of the photogrammetry was, I think, probably from my experience of doing it, something where people said, I need to recreate, I need a 3D representation of this. How can I do it? Laser scanning at the time, when this all came about, was like an expensive way to do things, where you had to buy an expensive tool. But most people had some sort of camera and were able to do the capture part of it. The software was pricey, but that's sort of changed now. So take some photos and create a 3D model. But that's pretty accessible, providing you know it exists, and you can say photogrammetry, because you do have to say it.
Yeah, absolutely. I was doing my voice stretches this morning saying that a lot. So is it similar to the likes of Google Maps, where you can go into the map and see it? I think there's a slight difference, but is it similar to that?
Yeah, so this is how the 3D representation within sort of a Google Earth or Google Maps is created, really, by combining pictures, aerial photos normally, to build up a 3D representation of the planet. So that is exactly what's going on in the background there. And a lot of computer game products now will be created using photogrammetry as a starting point. It used to be the way that you have to create an object in a piece of modeling software, like a 3D modeling piece of software, then apply textures and things to it and color it in, and the art was getting that as realistic as possible, where a bit like the art of painting is, perhaps if you're trying to do a portrait, is to try and represent someone in paint. There's a sort of an inherent skill in there. It's someone's job. Whereas the photogrammetry version of it is take a lot of photos and let the computer build you a 3D representation that's got a level of realism to it. So yeah.
Okay, so although you said that it's not how we take holiday photos, and I'd say the majority of us, unless you're my dad, use a phone for doing that nowadays. So yeah, we won't go down that route because we'll be here forever. But I'm pretty sure I've seen somewhere on the internet you did actually take holiday photos in a similar style or fashion, or you created something at least that was very different to your standard holiday photos. I probably put you on the spot with that, but I did actually watch it.
Yeah, no, well, no, that was part because so I permanently don't know what I'm doing. I'm interested in this world, but I know I don't know enough. So and I think for this sort of reality capture world, there's not really a reality capture university degree you can do. Perhaps there will be in the future, but right now it's not there. So everything you do, you see, and you go, I have to try this, and I have to work out where its limitations are by really seeing where it fails. And did it fail because of me, or did it fail because you've reached the limitation of whatever that workflow is? So the holiday photo video you talk about was really me going, well, I could take pictures of these things in a standard holiday photo way. Oh, there's a nice castle, snap. There's a nice feature of the thing, snap. Or I could create a model for everything I see that's of interest. So I was literally going along and doing photogrammetry type models of objects as I went along, and then rather than putting them into a slideshow, then I put them into a fly-through animation. So there's a random selection. I think the one you're on about is a big owl, And then you
Yes.
sort of go in through the head of the owl, and yeah. It's a bit random, but it's literally the owl became the container for all the things in no particular order. Possibly a slightly more engaging way of telling the story of where you've been to. But the main reason I was doing it was because I didn't know how to do it. And so the output is a
Right.
combination of my learning exercise across the holiday. And, having the family going, what are you doing? Why can't you just check? Why are you here? So it's trying to be efficient with it, so efficient that I didn't get in too much trouble, wasting time. Yeah, that's exactly it. So perhaps it could be holiday photos, and perhaps it will be. I
Yeah.
certainly now one of the biggest use cases I'm finding, when I'm not working, is actually taking pictures of birthday cakes. So birthday cakes are often beautiful. They're often, you know, there as a picture or a video blowing some candles out. But the actual beauty of the cake, which may be an expensive piece of art in some cases,
Mm.
it's sort of gone. And even the person that made it has probably just got a photo of it. And I think the question is, why wouldn't you take, you know, 50 photos of it, or not even photos?
Yeah.
We don't really do this photogrammetry stuff quickly with photos. We hit video, record a video, go around the cake, and then let the computer take the stills out of the video and reconstruct it. And yeah, it's a piece of cake. It takes about two minutes to copy a cake, and it's there forever then.
That's brilliant. I love that. That's ingenious. I'm just
Cake.
thinking of all the times you see a photo of a cake and it's never as good, like you said, as seeing it in 3D or being there at the time, because well, it's cylindrical, so that there's many sides to it. I
But
really like that.
why wouldn't people that are making cakes do this? So before
Yeah.
they deliver the cake to you in the box, say, I've done the cake now, and I'll text you. I can text you
Mm,
a cake, an image of a cake, and you can open it on your table where you were going to put it for the party and go, oh, it's big, isn't it? Oh, yeah, it's not big, is
mm.
it? um, and
Oh,
yeah,
not just that though, but from both sides of that argument, not argument, but both sides of that idea, is that one, you've got somebody making a cake and they've got that additional utilization of technology for communication and better comms, and then on the other side, you've got the person that's buying the cake that it could be just a small thing, oh, can you make that hat blue, not red, a tiny little piece, that
yeah,
would make a difference to them, and they're not arriving at your door and you're opening it and going, "That's amazing, but I
mm,
wish it was red, not
yeah.
yellow." It's like, yeah.
And what we're sort of discovering, and even although we didn't know we were talking about cake at the start of this, but ultimately the and this is what fascinates me about this sort of reality capture type work, in that it is absolutely universally useful to everyone.
Mm,
Um, we're talking about how to send a cake to someone so they can have a look at it. I mean, why couldn't you say the cake's red? Oh, not that red. Oh, right, okay.
yeah.
We're having a discussion about something and ultimately saving embarrassment. And you take
Mm,
that. That could be a cake discussion, or it could be a discussion about moving a massive piece of equipment from one manufacturing facility to another and saying, does it fit? Have we checked this? Because this could be, expensive, and it could be sort of a
mm.
grown-up use case of it. But why wouldn't you use it for the other stuff? Because the actual process isn't different.
Absolutely, yeah.
You've
I
got to
think we
know
see
it's
that
a
in
thing.
in a we see it in a lot of technologies, don't we? That they work both ways. One, it starts with a simplistic idea that's grown and developed into something that helps larger in bigger industries, if you like, or the other way around, where you hear it time and time again that NASA were using this thing that's developed into this thing, and it gets smaller and smaller until it's more commercialized, and then lo and behold, you're lying on a mattress that was once a spacesuit kind of concept or whatever it might be.
Yeah,
Which brings me nicely on to something that is of interest to me. And all technology has an entry point, and like we were just saying, that can kind of scale up or scale down, and it depends on your own knowledge and the equipment and how far that equipment can go, like you just said. So if somebody wanted to get into this kind of tech with 3D and photogrammetry and all that kind of stuff, what's the technology behind that makes this stuff work? What do we need, and what are the main barriers that we might come across?
Well, I mean, I think again, this is where it's interesting, and this is why I think at least I've got a job at the moment. Is because the barriers to entry are just fallen. So if we talk about photogrammetry, for example, so when I first looked at photogrammetry, I was happy because I could start because I had a camera. I had a phone camera or an SLR
Okay.
camera to take the pictures. I was fortunate at the time I was working for a company that had a sort of software license for some of the photogrammetry software because it was a really expensive tool. So there's a barrier to entry was the software cost £2,000 or £3,000 a year for something for copying cake. You might not make that much a year on cake. So that would get your cake use case out the door straight away. But that was the barrier to it. And then computing power. So you needed a decent computer to be able to do all these calculations to work out where the photos were taken. But roll forward to today, we could, whilst we're on this call, we could get onto our phones, onto Google Play or the App Store, and we could download a piece of software like Polycam or a free piece of software like Scaniverse, and that would you'd install that on your phone, and it would prompt you to start taking pictures. It even gives you sort of like a visual guide of how you should be taking pictures of the object. You would record video, take pictures on your phone. Most people have some sort of camera phone these days, and then hit process, and it would either process on device or send it to the cloud to process. And in 5 or 10 minutes, you'd have a 3D model.
Nice.
Which you can text to someone else, and they can open in augmented reality on their desk, or they could look at what the model. So actually, the barriers to entry are currently limited by what is photogrammetry? What is this? I can create that with my phone. So the barriers to entry are really knowing that it exists. It's like I say, Scaniverse is completely free. That can use
Wow,
the phone LiDAR sensor if you've got a LiDAR sensor. But if not, don't worry, because just photogrammetry, which is just photographs, then it supports that, and yeah, you can go off. And what that should be doing, assuming people have know it's there, it should be then prompting people to use it and go, oh, that didn't work. Why didn't that work? Or that's really good, but I'd like a higher resolution. I'd like a more complex version of that. I don't want to copy a cake. I want to copy a room. I want to copy a building. I want to copy a city. I want to copy a continent. Then you start. Then the barriers to entry become higher, but because the tools you're using are slightly more sophisticated. But knowing you can even do it is the barrier to entry at the moment.
Okay.
So
yeah, cool. So hopefully people that are listening will at least give it a go, and then they'll understand the simplicity or complexities of what goes with that. In terms of the technology and the equipment, I know we've mentioned a few apps there, and we can utilize our phone. How advanced are these things? Have we got a long way to go with it, or are we coming to almost a point in time where there needs to be a giant leap forward or a step change in this kind of tech that we're using?
yeah, well, I think there's changes happening even within this market. So photogrammetry has been around for a while, albeit not phone photogrammetry, but it's here now. What's more interesting at the moment are sort of AI enhancements of photogrammetry that might be called NeRFs or Gaussian splats. But loosely, these are techniques where you don't necessarily have to have all the data to reconstruct something. So filling in the gaps, AI filling in the gaps to reconstruct objects is sort of fascinating. It means perhaps you need to be less thorough in the way you capture things, but it also means you can use historical resources where somebody might have recorded a video of a seaside town in the 1920s, and you're now able to reconstruct 3D models of that town from historic video, which is sort of
Wow.
mind-blowing, really. So
Yeah.
you could go and have a look around a place in 3D, which you only had a sort of a grainy video of from the
That's
past.
cool. Yeah.
So, which sort of makes you wonder what they're going to be able to do with the endless photos that I've got captured on my iCloud account now, or in 100 years from now. What on earth?
Mm.
What on earth will we be able to do with this historical data? I think in terms of where it's going, that's sort of, and it will be, the tools to capture environments. It'll be wearable tech that you're just wearing as a matter of course. Perhaps you'll be wearing some sort of augmented reality glasses, and as those augmented reality glasses are, measuring the environment to give you information feedback, perhaps at the same time they're also sending data about what you're seeing, and then recreating 3D representations of the world you're in instantly. So somebody walks down a street, and there's a new 3D model of that street recreated and updated, and perhaps compared to what that street was like, 5 minutes before. A driverless
Wowzers.
vehicle going through a centre of a town. If a dog runs out into the street, then perhaps the avoidance of the dog will be, well, first car sees dog, sends an updated, instantly created 3D model of that environment, the way the dog ran out, and tells the car behind it there's a new model being created, and then the car brakes and avoids that. Perhaps that's where it is. But then, so we're talking about limitations now in how fast we can get from start to end, from observing something to having an output and then doing something with that. But that is getting squashed and squashed and squashed and squashed all the time. So yeah, and even with, like I say, go back to photogrammetry, which was take a load of pictures, download it off the SD card, put it on your computer, fire up that piece of software, run that software, go home, wait for the next day, realize it's failed, do it again, another day goes by, and then you've got something that nobody can view because it's massively complicated. I just got my phone out and looked at the cake. Go back to cake again. Go on the cake video. 10 minutes, it's done. Share it with whoever you want. That's just going to get shorter.
One thing that I find really interesting is, and you can find loads of articles like this, and they usually do with like Star Wars or Star Trek or some kind of 80s or 90s futuristic program, and it's things like the top 10 things that were in Doctor Who that are now a reality, and it's weird because those things now we take for granted, but just 15-20 years ago they were just on Doctor Who, they were just a Star Wars thing or whatever it might be, but now they're just part of our standard normal reality that we take for granted. So there was a report by Autodesk that said with all this kind of tech that we should always begin with an end in mind, going back to the very start of the intro, saying what is the point in this technology, and that the way we use it should always be actionable or lead to at least further actions or have some value and benefit to a project if we link it back to construction. So what would be a standard, if there is a standard, but what would be a standard process here from kind of the decision to use technology to the end result?
Yeah. So I completely disagree with that view from Autodesk. So,
Okay.
And the reason I say that, you've got to you start with an end in mind, but actually, if nobody really understands what you're doing at the start, then you can't have an end in mind because you don't really. People haven't had chance to see it and understand it and know where it's going. So, and I just start lots of things with no end in mind, and this is like the fail fast type thing. So I start doing something, and I don't know where that'll go. I often start things because I think I wonder whether that would work, and but then people say, oh, could you use it for this? And you go, right, now we're doing brief discovery now, but before we did this thing, which may be ridiculous, then you didn't even know that existed, or perhaps didn't allow enough time for you to think about it. And this is, so this is sort of, the formula to quite a lot of the content I create. It's sort of pointless, really. It doesn't mean you're not allowed to ask what's the point later, but it's sort of pointless for the hook. That lets people go, that's ridiculous. Why would you do that? It is quite impressive, though. I wonder whether it could be used for this. Why would you go down a log flume with a laser scanner? What is the point? What are you going to get from that other than a wet laser scanner, possibly some broken technology? Well, it might not work. It might work. I don't know whether it'll work. And the opportunity arose, so why wouldn't you do that? But if it can map a log flume as you're going down the slide and map that world as you go through it, definitely going to be able to do an office. And you don't have any plans of your office, and your office has got some fire evacuation challenges, and you need to look at and share that idea, that 3D problem with someone. How would you do that? And then once you've copied that, then perhaps you want to know, once you've implemented the change, how well those changes work, or what actually you've changed. And then you get into this, could we do this with it? Could we do this with it? Yeah, probably. I'm glad you asked the question, though. So I think sometimes you have to start things with no end in mind to allow people to observe and go, could you do this with it? And then you generate the what's the point retrospectively. Don't get me wrong,
And
you can't live your life completely like that, but I think there is something to be said for just getting on with things and then seeing what happens.
And I suppose if you do have an end in mind, then you are putting a limitation on what could possibly be, and you could potentially be boxing yourself in and just focusing on where you feel the limitations are, rather than jumping on that log flume and seeing what happens.
Yeah, absolutely. So perhaps when you say the end in mind, perhaps the end in mind has to be loose. Like, it would be nice to create a digital copy of the log flume. Why? Because it's interesting. Because it's just an interesting shape, and you can get your basic use case for reality capture from just understanding adjacencies, where things are. Where is the top? I imagine the bit where before you go up the log flume and drop down, that's lower than where you start, because the water has to flow around, right? So, but how much lower is it, and how long is that? How much do you have to drop before you get to the start? Perhaps there's some design guidance on it, but if you don't know what that design guidance is, if it works there and that's 1.5 meters over 500 meters, then, well, that works. That's empirical, isn't it? So, and I think there's a lot that can be done in sort of our built environment from just observing what's there. And we see this with organic design, where people say, well, this was inspired by sort of this tree or this plant or whatever, and it's sort of the same, really. You're saying, well, if I could measure that and capture it, then I can analyze it, and then we can sort of do whatever you want with that new knowledge that you've got.
Okay, so I can't leave without discussing examples here. We've spoken about log flumes, we've spoken about cakes and holidays. Are there any projects that you've been involved in, or are involved in, or are going to be, that you've seen a real benefit from using photogrammetry or the latest technology? And then, do you have any more passion-based projects, or something that you've just done that's a bit of fun that's really interesting?
Yeah, so I mean, I suppose the easiest one. I mean, my background is in construction, right? So I spent a large portion of my life designing, heating and cooling systems for buildings, and then conveying that idea, having to change that idea because it was not enough money for it, or coordinating that idea with people, and then putting it in, and then once it was put in, validating it, make sure it was right, and then handing it over to someone else saying, right, this is yours now for the next 60 years. Off you go. So I've done quite a few projects now where just in its simplest form. So feels like the construction design world has jumped for BIM, this building information modeling, quite quickly. And I think from a design point of view, that makes sense, because ultimately at design stage, what you're doing is, trying not to collide with each other. You're trying to coordinate the design in 3D, and that's where historically things have failed. The most useful bit of reality capture I've seen relating to the construction world, that I've done on a number of jobs now, is actually using, not lasers, not really photogrammetry, just using straight video. So 360 video, that you go to site, you walk around the site with a video, upload it, process it. The processing is basically stripping 360 photos from that video and then positioning them automatically on a plan. So there's nothing to be done by the user. All the user has to do is say, well, I started at the front door to the building. Walk around it in any route, doesn't really matter, because the computer is able to work out where the video recorder's been for that journey and put things on a plan. It then means that you can say, all right, could you go and walk around that site and do the same thing again? Same process, walk around in a different route, and it will bring up 2 360 videos that have been taken side by side, so you can spot the difference. And so the technology to do this is quite advanced. It puts these things, aligns all this stuff for you, but in reality, what you're doing is a straight spot the difference exercise. And the reason that's interesting is because you need to know what's changed as you're building sites or building things, but you need to make it accessible. And saying, can you install this piece of software and use this piece of 3D tool to navigate around and get to the same place? And that's sort of intangible for a lot of people. It doesn't enhance the way people do their jobs, whereas this is so easy to use, then it's instantly valuable. Then you can align that 3D those pictures with models and do that. So I'm doing a lot of that sort of stuff at the moment, and saying, this is so easy, you should do this. So there's no point in having technology that's just limited to use by specialists, really. These digital tools and techniques should be available to everyone, really. So that's a project I'm working on a number of sites at the moment. The sites, obviously, people don't. The sites are in various different places around the country, but some quite high-profile sites that just allow everyone to engage in that construction process and have their view during the process rather than at the end. And that's when everyone draws their guns and gets lawyers involved. So that's really quite good. In terms of sort of, oh yeah, go on, carry on.
Yeah, I was just going to say it rings true of that openness, transparency, and collaboration within construction that can fundamentally help the whole industry. If we all start to do that a little bit more, and it rings true to what you were just saying there. I'm keen to know if there's any passion projects or something that's I nearly said a bit more fun then, but I'm not going to go down there. I'm just going to say.
So that is, I suppose the fun comes from seeing how, when people start using it and you go, honestly, it is as easy as I've just tried to explain, you have a go, and they do it and they go, this is brilliant, we're just going to use this everywhere now. So I think that's where the fun or the joy comes from me, when you see that sort of moment where someone goes, wow, now this is going to transform the way we do this. I wish we'd had this on this project. So that's where the joy, the joy project. So joy projects I'm involved with, and joy projects that I want to do in future. So one of my current projects I'm doing, I'm creating a replica, a digital copy of Old Joe, which is a clock tower at Birmingham University. So you wouldn't possibly know it, but you might see it a little bit more once this piece of work's been doing, because it's the tallest freestanding clock tower in the world. So it's cool. On my doorstep in Birmingham. Amazing building. A lot of people go, "Oh, what's inside it? What is it? What is inside this tall structure?" So so what I've been doing is I've been using sort of 2 almost experimental pieces of equipment to copy it. So I've got a long range laser scanner, so it's got a range of between 0.5 meter and 1 kilometer for measuring points on buildings and creating a point cloud at the outsides of the building, which is good because we don't want to be flying drones around sort of the university campus, or that you can, the risk of getting into the air above a load of students is just not cool. And then the indoors, because it's just a gnarly space. Actually, what it is, it looks like a Tim Burton movie inside. It's just like an impossible clock tower. You'd expect the Joker and Batman to be having a bit of a fist fight inside on the staircase. That's what it looks like inside. But quite tricky to copy because it's very vertical and it's quite compressed. So I've been using sort of tools that came out of the mining industry for mapping the insides of the building, so you can see all the staircases and the intricacies, and you can just see how much there is going on in this building. That's just like a 1903 piece of engineering genius. And the replica, what will it be used for? Well, a lot of people said, why are you doing this? What will it be used for? Well, in its first case, it will be used just to show people what it is in a way that they can go, oh, right, I often wondered how you got upside. There's a lift in there. There's a lift in there? There's a big water tank in there. Why is there a water tank in there? Because that literally is the tank that pressurizes the whole of the university, like a big feed-in expansion tank, but that you'd have in old heating systems in houses. That's why it was there. And there's a clock, and there's peregrine falcons nesting in there, and all sorts of crazy other stuff. But yeah, so in its first case, it would be to show people what that's like, without having to open the doors and let people in, because there's all sorts of health and safety challenges with that. But to get an insight, that's what it'd be used for. But you've done this copy, it's using laser, it's repeatable. Oh, well, I could do it in 5 years from now, and tell me what's changed by more than 10 millimeters. But yeah, okay, I can do that. Just compare the two things. So it might be that. It might be for modeling the externals of it. It might be because they want to sell versions of old Joe in the Birmingham University gift shop, and they can 3D print it from it. It might be for staff onboarding. It might be for used as the input material for a training course on how to use the fall arrest system that's in there. It might be to tell the lift engineer that's never been there what they were dealing with. It might be to study the flight paths of peregrine falcons around clock towers. It could be, somebody will see it and somebody will draw some conclusion about what they could use it for. And that's a fascinating thing. It doesn't really change the start process though. So the start process is, we're going to create a copy. What tools are we going to use to do that? So that's one at the moment. One I want to do, I'm really interested in cutting holes in the landscape, and not in a really particularly destructive way, but I did a proof of concept of this actually, and it worked quite well. So I just want to do it bigger now. But loosely, if someone sends me a shape, so in this case I was doing the proof of concept was for Mighton Hospice. So they got a butterfly as their logo. So I put the butterfly into a piece of CAD software, pushed it into a little bit of augmented reality software that uses GPS to locate the augmented reality. So not like put a dancing stormtrooper on a table type stuff. It's locate an object in the real world, and the real world is defined by its position, GPS position, and then that overlays something on the landscape, and then you can use that then to mark out. So what I did was I got this butterfly logo, overlaid it on a mate's field, used the tool where I could see the butterfly in the real world, walked around with a spray can, just sprayed bits of the field for the outline of the butterfly, and then invited my friend round, told him just to bring a strimmer with him, and we cut the shape out of the grass, probably about 30-meter size butterfly, and then just flew a drone up, and you could see this bit of sort of almost like bioterrorism. So cutting the grass, the reason we eat grass is sort of grass recovers itself quite nicely, and it's you're not really damaging the world particularly by doing that, but you are able to create this logo, which if you're in an airplane flying past that week, then you've definitely seen that logo on the ground. And I'd like to do that bigger, a bit like crop circles, but slightly more advanced version where you could do anything. If you want to put your name in the grass, then just give it out, put it on the ground, and we can cut your name into into the grass. But it could be done with chalk on concrete as part of like a schooly community engagement thing. It could at the moment be done by just telling a load of people, right, there's some flags on the field, just walk around inside the flags, and you just create a muddy mess with inside the flags that would actually may represent, something that you can see. So it's a bit of a like an art attack type thing,
I was
really.
just thinking that one
But
for the
it's
one for the
using,
younger generation there.
these tools are meant for checking whether the the drain is in the right place, or whether that civil engineering flyover piece of work is where it should be. But yeah, misuse that all day long. So
Absolutely. I once heard that. I think they used a cow as as the hypothetical scenario, but as long as you've got the details, you can write a check on anything. I don't know if that's still the case, or even if that is true. But I was told that as long as the details are correct, you can write a check on absolutely anything. And they said if they write it on a cow and took it into a bank, then it would be legit. So I'd quite like to do that in grass. Write somebody a check.
yeah,
That'd
write a check.
be quite cool.
Perhaps to Mighton Hospice, as a hospice.
There you go.
We'll write a check. Let's do that. Get some
Fantastic.
donations, and we'll just have to update the final donation amount just before we get the streamers out. So
Brilliant.
or the robo
Let's do it.
It's the robo. That's the robo thing. But yeah, no, something like that. I mean, the interesting thing is, I think you've got to do stuff that makes no sense, because there's a loose why for that. But in doing that, we said, if you can do a butterfly in a field, then you can definitely do a new utility supply underneath a main road, can't you? Yeah, you can, absolutely. But you were more interested in the butterfly, and then you've drawn that conclusion. If I did the utility through the road thing, then you would have probably gone, oh yeah, that's interesting, and everybody else would have gone, what about that? I'm not going to engage. And because it's open to everyone, this thing, and it can impact everyone, then you need to sort of find a way to engage everyone. So
yeah, for sure. And I love the fact that you brought into it the barriers to entry can be quite small, and then it's about understanding what the heck it is, and then jumping on board and trying it and testing it and failing and making sure it's right for fit for purpose or whatever you want to do. Derek, thank you so much for coming on. I never thought on this podcast we'd talk about cakes, log flumes, holidays, and old Joe. They're new ones for me.
That's construction disrupted then.
I think
a perfectly good construction tech. Next time we'll come on, we'll talk about survey control and setting out piles and things like that, if that's useful. But yeah.
Absolutely. I think we've won the podcast game there. End of the road, I think, for this podcast. Now we've won it. Derek, thank you so much. My absolute pleasure coming on. Thank you for your time.
No problem. Thank you for inviting me.